electrical. So some electrical, some automotive, and some of you wanted to see welding this afternoon and had to get rescheduled at the last minute, right? All right, so my bad on that, but hopefully, or not my bad, but my apologies on that, but I hope y'all enjoy this. So this is Mechanical Engineering Technology program here at BCCC. I'm Matt Holliday. I'm lead instructor over the program. I've got three very top performing students here to help me today. I got Mr. Gabe King, Dawson Woolard, Jacob Van Geisen. All right, Gabriel King and Dawson Woolard. Appreciate it, Jacob. That's interesting. He actually designed the part that you guys are getting ready to see. So Gabe wants to make sure everybody knows he works for Fastenal, local industrial supplier. If anybody needs anything, call him. And Dawson is a machinist apprentice at a local company. They're both well ahead in the program. Gabe's actually graduating in May. Dawson's a little farther out, but doesn't have too many classes left. But they're two good students, and I greatly appreciate them being with me today. On that note, I would love to just go around the room real quick and have you guys introduce yourself to me. Tell me whatever you want to tell me within reason, and what school you're coming from. So we'll start right here, please.
My name is Portia Walston. I'm here from Beaufort County High School, and I serve as the career development coordinator.
Hertford County, you're up there a little bit. Yes, sir.
Ernest Greenis, I teach at the north side. The subjects I teach is electrical trades, carpentry, drones, and I have taught football. I coach football. I coach Gabe.
I was like, I thought I remembered you.
And we worked together a long time ago, but he doesn't remember me.
I do.
Yes, ma'am.
I'm Tina Nelson. I'm a school counselor at Burt T. High School.
Burt T. I had a couple of Burt T. folks in my first group this morning. All right. Yes, ma'am.
I'm Jessica Jacobs. I teach at J. Rose High School in Greenville, and I teach business and IT, currently computer science, Microsoft Excel, and
Awesome. Yes, ma'am.
Carla Jones. I work at Bowling Central High School in Pitt County. I am the career development.
Career development. Yes.
I'm Melissa Moore, teacher at Washington High School, visual arts instructor, and I believe we might have taught my son right now, Brady Moore.
Brody Moore. That's at ECU. Well, yeah, I have had some classes with him. Yeah, he's had classes with me. He's a good kid. Yes, ma'am.
I'm Rebecca Rebels. I teach health science, Smart County Schools at the Innovation Campus. New to teaching background in physical therapy. So.
Oh, yes, you look very familiar to me. The Innovation Campus behind Bojangles?
Yes.
Yes, okay. I'll stop at Bojangles. All right. Yes, ma'am.
Sarah Whitfield. I'm a science teacher at Washington High School.
Science. Thank you.
Louise Byrne, ELA at Miami School.
All right. What's that acronym? So what'd you say?
English Language Arts.
Oh, ELA. I got you. English. Got you. Yes, ma'am.
Buffy Everett, Southside High School, agriculture teacher.
Agriculture. I did a career fair at Southside last fall. Yes, ma'am.
Louise Salerno. I'm the high school science teacher at Beaufort School.
Awesome. No science teacher. Yes, sir. Hertford County. Hertford County. What, Harrowsville, somewhere up that way? Yeah, you're getting on up there now. All right. Yes, sir.
William Peel, assistant principal at Burt T. High School.
Burt T. And then
Jack Byrne, Fairgrass Charter School, drones and construction.
you've got to coach something.
A lot of stuff.
Okay. All right, cool deal.
Earl Pennant, the one looked like a tennis coach.
Cool deal. All right. So I'm lead instructor over the program here. Very local, about as local as you can be. I'm from Janesville up the road, Martin County. You look very familiar to me. So yeah, who knows? You're married to a Rebels. One of the twins. Okay. One's a police officer, one drives trucks, or vice versa. You're married to the police officer. Okay. Okay. No, I haven't. I knew there was two.
I have to be careful how I answer that.
No. It's just a small world. I dated a girl from Beargrass many years ago. All right. So everybody's here. Thank you for being here. So mechanical engineering technology. Does anybody have any idea what mechanical engineering technology is? Awesome. That's why you're here, right? So that's the point I always like to try to make is, electrical, got a pretty good idea of what you're getting, to some extent, or what the field is at least. Automotive, pretty good idea what the field is. Welding, pretty good idea, so forth, so on. Mechanical engineering is the broadest of the engineering disciplines. We've got a pretty good feel for what civil does, environmental, electrical, structural, computer, so forth, so on. We got a pretty good feel for, the field, of each of those areas. Well, mechanical is like the catch-all. Mechanical is the jack of all trades engineering discipline, and we cover a wide gamut, a very broad scope of topics and subjects in mechanical engineering. And most community colleges that offer mechanical engineering programs tend to narrow down and focus on manufacturing. And that is exactly what we do here. We focus on manufacturing, and when I say manufacturing, we primarily focus on machining, on producing parts out of metal, is basically what our focus is here. And that's not unusual, and that's a very common industry in this area. Just off the top of my head, we've got Carver Machine Works, Flanders Fielders, P&G, Canfield Ford right here in Washington. We got Heister Yale in Greenville, Pinco up in Hamilton. That's just off the top of my head some very relevant industries to our program here. On that note, just FYI, I've got more employers looking to hire out of my program than I have students. Okay, I've got a lot of people looking to hire. This is a very in-demand field, and it's a field that people aren't going into, just like most of the vocational trades and technical trades. So if y'all have any students that'd be a good fit, or young people that'd be a good fit, or old people, or middle-aged people, whatever, send them my way. I'll be glad to have them. So on that note, today we're going to kind of walk you through the design process. I thought I had a pretty good plan laid out, and it kind of went over like a lead balloon with the first group this morning. So I'm going to try to change up a little bit. But our program, everybody should have a flow sheet for our program. Does everybody have something like this sitting in front of you? If not, we can hand some around. If you will just pass them around. So this is the curriculum flow for this program, and I like to share this with you guys because just so you can get a feel for the courses that we cover, that we offer. A very wide breadth of material. We start out with some intro courses, of course, but we're heavily focused on modeling, on CAD. Everybody's heard the term CAD by now, right? Computer-aided drafting, computer-aided design, computer-aided modeling, however you want to refer to it. All right, so we're very focused on computer-based modeling, so we can take conceptual designs or conceptual ideas and actually create models out of them and get them in working space, create prints, so we can start working with real-world ideas, and as the first step in actually creating a real-world physical part, a real-world physical component, whatever it may be. So we focus a lot with the CAD, the computer-aided drafting and design side of it, and then we shift gears into computer-aided manufacturing, which is where we take those computer models and basically generate computer code, CNC code, from those models that we can send to a machine and physically produce the part. Well, how do we physically produce the part? Well, historically, machining as we know it is what we call a subtractive process. We start with a piece of stock, we start with a piece of material, we start whittling away at it, cutting away at it until we're left with a finished part, right? I mean, that's just how we've known it forever. Here's a good example right here. Everybody knows you don't have to know anything about carpentry or anything really, but you could tell that started as a block of wood and the material was cut away. That's just reality. Well, so we call that side of it subtractive manufacturing because we start with stock and we start to subtract material away. We start to take material away, and that is obviously a very common style, a very common approach to manufacturing that's been around forever. So I heard a couple of science teachers, but I don't think I heard any history teachers. Well, when I talk about machining, when I talk about manual machining and a machine called a lathe and a machine called a milling machine, all right, any idea how far back that goes? No history teachers. It's basically the precursor to the Industrial Revolution, basically what caused the Industrial Revolution. Everybody's heard the name Eli Whitney before, right? Eli Whitney and his cotton gin and his interchangeable parts concept with muskets is basically the groundwork for machining as we know it to where we are today. All right, so when we get out of this lab, we're going to go to the manual shop, and we're going to see how things are done manually on the milling machine and the lathe. And there's still a place for manual machinists. There's still a lot of demand for manual machinists, but in a production environment, now we go into more of an automated environment. We go into more of a CNC, which stands for computer numerical control. So the machine processes are the same, but instead of it being manually operated, it is computer operated. So that's the two big gamuts on subtractive manufacturing, or specifically machining. Manual machining and CNC machining. All right, so the next big category of manufacturing, as we know it, is called additive manufacturing. And most of you are probably very familiar with additive manufacturing, because every one of you in here heard the term 3D printing, 3D printer. What we have running right now, these two machines that you hear running and you see moving, they are 3D printers. That is just a general term for the broad category of manufacturing known as additive manufacturing. So with subtractive manufacturing, we have to start with stock, and we start cutting away stock, wasting stock, however you want to think about it, to make a part, to make a product. With additive manufacturing, we start with nothing. We start with just a blank slate, and we start building up a part at a very thin layer, very thin layer, very thin layer, so eventually we're left with a finished part. Now, a lot of people still consider 3D printing to be a hobby. You know, a lot of kids have printers in their basement or their bedroom or wherever. Both of these kids, I call them kids, both of these young men right here have their own printers at home. It's very common. 3D printing is very affordable and very accessible. You can buy a printer like that for $200 or $300 online. The filament needed for it, you can buy for $20 off of Amazon, and the software is free on the internet. What more could you ask for? So, you know, $300, you're printing. You're printing real world parts. You know, now that's obviously very low end, very basic level. You know, some of you moms may have bought a printer, I don't know, and have a better idea what the prices are. But 3D printing has become very common. All right, and for the longest time, such as like when I was going through college, 3D printing was considered rapid prototyping. So you created your model, you created your prints, and then if you needed a sample, if you needed a prototype, then you could print it, and then you'd have a sample prototype to base your decisions and your changes, your engineering changes on with that real world physical prototype. Well, the 3D printing has the technology of 3D printing has improved to the extent that now we can actually produce real world usable parts. And so far, I'm talking strictly plastic. I've got somebody looking at me already. All right, but metal 3D printing is a thing too. Metal 3D printing is still very much so expensive compared to plastic 3D printing, but metal 3D printing is a possibility now. ECU does have one 3D metal printer, and it's basically a process where you lay very fine layers of powdered metal and then fuse it with a laser, layer by layer, to get a 3D printed metal part. So with that being said, today we're going to kind of walk you through, you know, the design process, the engineering process for a basic part. And what I have up right now is way too far ahead, so just ignore that. So everybody should have up on the computer in front of you, and I know everybody's having to share a computer, but you should have a screen that looks basically something like this right here. Fair enough? All right, this is a software called Autodesk Inventor. Autodesk is one of the main names in AutoCAD software. And go ahead and let you know, for educators and students, Autodesk provides all their products for free. So just keep that in mind. So on this screen right here, let's go ahead and up under your left-hand corner of your ribbon bar, let's start a 2D sketch. Start a 2D sketch.
3D sketch.
Lad, we're not ready for a 3D sketch. It's just go to that drop-down menu, that arrow. Let me drop just a second. Yes, sir. So here's the point. This is where I always like to make this point. Anytime you have kids that say they're never going to see math again, what just came up on your screen is their Cartesian coordinate system. Everything we do is based on coordinate pairs. Everything we do in our modeling, our drafting, and our machine programming is based on XYZ coordinates, Cartesian coordinates that we have learned ever since we're in 4th or 5th grade. I always like to throw that out there to my kids. You're never going to get away from Cartesian coordinates. You're never going to get away from trigonometry or algebra in this field. All right. So at this point, everybody should have a screen that looks like this. So if you will, single click on what's called the XY plane. Now, we're just going to, I'm just going to walk you through, modeling a real simple part real quick. On the left-hand side, top ribbon bar, let's select the line. Just select the single line. And then in your drawing area, left-click once, and then drag your cursor wherever you want to drag it. And then left-click again, and you have drawn a line. Continue doing that and draw basically whatever you want to draw. Yes, I mean within reason. I mean, show me how good you. I don't. Oh. Now that is intense right there. What do you call that? What do you call that? That's intense. All right. So what you can do? Get out of that command. So just okay, and then a couple ways we could do this, but the easiest way is just going to be to select all, delete. Look at this, looks like everybody's doing great. All right, so we have drawn a rectangle. It's irrelevant what the size is. Now let's come put some other feature on the inside. All right, now come up to your ribbon bar immediately to the right of the line command, and let's select circle, center point circle. Come inside your rectangle, single click to drop the center point of the circle, and then start dragging out and draw. As long as it stays within the confines of that rectangle. You can just drag it out, or you could actually enter a dimension, however you want to do it. And then come over to the opposite side and do the same thing again. Just draw you a circle of some size. Does everybody have something that looks remotely close to that? Yeah, I mean, that's all we're asking for. You want a hand? You want a hand? No, you're fine. Here, we'll make it quick. We're going to use a rectangle command. Just drag and drop a rectangle. All right, I see. Somehow your line type has been changed.
Yeah, that's what was confusing me.
Your line type. So that's going to make all the difference for you. All right, let's finish sketch. Now let's just create a new. Let's not there. Let's create a new sketch. Just to let you start from scratch. All right, start a sketch. Now things should start to look different for you.
Okay.
All right.
Yeah, that's what was missing.
And then, yeah, sorry about that. I'm not sure how that happened. Center point circle. I'm just going to drop a circle in there. Then I'll come over here and I'm going to do the same thing again.
I wanted to see what if you look at it.
All right.
Okay.
Not fly.
So you can call it whatever you want. I mean, kind of looks like a stovetop or an old stereo or something, whatever you want to call it. All right, so I just want to show you a couple of features of this software real quick. So let's say we want to make a slot out of this. So let's connect these two circles. Let's take a line, make a line, take our line command, and let's just draw a line tangent to the top of both circles, and you're like, well, hold up, I only know what tangent means. How do I do that? Well, if everybody will watch me, I'm going to show you one of the neat things about this software. One of the powerful things about the software. Just draw something arbitrary. It doesn't matter what. You know that that line's supposed to be tangent to the circle. So now come up here and select your tangent constraint. Select the line, select that circle. Line, circle. It's going to make it tangent. Now it may shift the rest of your model to make it work, but it's going to do, the software is going to do whatever it has to do to make that constraint true that you just gave it. All right. And now, right here. We have geometric constraints and we have dimensions. That's two things we're working with. I'm just assuming this back row is good. I'm not even walking back. Oh, that looks amazing. I don't know what you call it. Yeah. One side did. Let me mind if I drive just a second. So we want this line to be tangent to this circle. There we go. Now you see that icon pop up. And you can tell that's not tangent because you got that little giblet there. So, there. You see how it actually moved? And now you could do, even though you're touching the bottom side here, you could do the same thing. There we go. Now if you can just take a minute and just play around, do whatever you can't mess up anything. Oh, you want to do what?
It's not centered anymore once I do the bottom.
Right. It's going to move whatever's not constrained to make the constraint you give it true.
Okay.
So
It doesn't look true anymore. It looked more true before.
where those lines are tangent now. So that constraint you gave it is true. These two circles are two different diameters.
That's right.
Is the issue. So what we could do, well, one, there's a couple different ways we could do this, but let's say that this vertical distance between those two center points should be 0. There. There we go. And now if you want to, you can come up here to your nice little trim command, clean this up. And now I'm going to go ahead and do the next step for you as well. Now we've got a slot. From 2 lines and 2 circles, we have made a slot. All right, what?
When I did the tangent constraint, straight the line, but it didn't connect to the circle.
Because, let's see, chances are, these are 2 different diameters. Let's see. We want this line tangent to this circle. There we go. I went to my tangent constraint, and then I selected the line, then select the circle.
Okay, line and circle.
Yes,
okay,
ma'am.
so I just did the line.
Right, because what you're doing, you're saying I want to take this line and make it tangent to this circle. Is what you're doing.
Okay.
Is what you're doing. And now I'm gonna trim out this little extra line here, and then I'm gonna go ahead and trim those 2 out. Now you've got a slot. Let's get rid of this little giblet here. I don't know what that is. There we go. That belt's slipping. So we can, all right, well, let's
Start over.
no, absolutely not. We can do basically anything we want here. Let's say we want to move this by its center point. All right. Yes, and now let's just simply move it. Now we're done with that. Now, I'll tell you what, we'll do this to keep it simple. We'll do the same thing again. We're going to move that circle by the center point. That's what it means by base point.
Okay.
And now just move it down here somewhere. Okay. And now, to really, all right, so we want this line to be tangent to this circle. And we want it to also be tangent to this circle. To make that true, it had to do that. So what we could do,
Move the line.
or we could move the line, Right now, I'm just going to delete the line. I'm going to delete this line and that little line. I'm going to add a vertical dimension between these two center points, a vertical dimension. I'm going to change that dimension to 0. Now they're going to line up. That's just one way to go about it. You don't have to do it that way. Now I'm going to come back, and I'm going to go ahead and draw my lines tangent now, or really close to tangent. And now, make that line tangent to that circle, line tangent to this circle. All right, easy enough, right? And now we're going to do the same thing on this bottom side. Line, circle, circle. And now, to go ahead and get you ahead of the rest of the class, I'm going to trim out. Whoa, trim my whole circle. And I know why. It's evidently I shouldn't have done that. Escape is your best friend with this software. All right, so the reason it's not trimmed out is one of these lines, we don't have what's called a closed region. Somewhere it's not actually touching.
I think it was at the top.
So, all right, I just extended that out and extended that out. Now I'm going to come back and trim this side. And let's see if that took care of it. Trim. There we go.
Okay.
Beautiful. All right, so, yes ma'am. All right, so everybody should be, there's really no right or wrong answer. This is just your time to play with the software. All right, so now I'm going to come back and I'm going to trim out the inside half of my two circles. And I'm left with that. All right, but so far, all we have done is put lines on paper. All we're doing is working in drafting space. This is 2D virtual paper space is what we're working in right now. I mean, this is the virtual or the computer-based equivalent of drawing on paper. All right, let's finish the sketch. And now let's take it to the real world. Let's make this a 3D dimensional object. I'm going to come up here to extrude. I'm going to select this region here. How thick do... I'm going to slow down. I'm going to come back. There. Okay. So now, back in the sketch. I'm going to go back in my sketch, so I'll be the same place y'all are. Once you've got something similar, come up here and click on Finish Sketch. Let's see what you got. When you trimmed it, it trimmed the whole circle because that line's not touching. So let's come do our tangent constraint. Boom. It was missed somehow. It happens all the time. Boom. There we go. Now finish sketch. Right there. All right, so does everybody have something they can work with at this point? Yeah, everybody's got... That's all right. All right, you're good. Yeah, you don't have anything to ask about. You're in good shape there. Let's see what you got here. There you go. You would just turn your view so you were looking at it from the very end. Look at that. All right. So this is called parametric modeling. We can go back and change it. At any time, we could go back and make edits. That's why it's called parametric. All right, what time did we get done?
We had to read that by 2:10.
2:10? All right, so we got 55 minutes. You need some help, sir?
Yeah, because I tried to redo something. I missed the whole net. Because I made another one and it didn't do right. I don't know where it went. I was trying to make a cup in there.
Take your job.
Say that again.
You don't have to worry about us coming to take your job.
See what? that's what we're gonna do. We're just
Yeah.
gonna start a new sketch,
Oh, okay, that's what I want to do.
and now I'm gonna draw a rectangle. All right, and now I'm gonna come in and I'm gonna draw 2 circles.
Right.
Wherever you want them, however you want them. It's just easier to keep them nice and. See how they snap? You see how that
Yeah.
line came in place? Now I'm gonna come draw
Uh,
a line from here to here, and I'm gonna come back and draw a line from here to here. Like, well, here's the neat thing. Now I can just come grab that constraint, and I can make them tangent.
oh, you grabbed it. I see.
See, and that's just telling me that constraint's already there, so I didn't need to do it.
Okay.
All right. So now I'm gonna come back and I'm gonna trim the inside half of both of those circles. And now 2 circles and 2 lines made a slot, made a radial slot, an end mill slot. All right. So now, once you've got something, I think most of you've got to this point now, but once you've got something, now we're going to finish our sketch. And now we're in 3D model mode. Come up here, left hand end of your ribbon bar, and select extrude. And select the rectangular region of your part. Decide how thick you want it to be. I'm going to make mine a 1/2 inch right now. Click OK. And we have just gone from 2D paper space to 3D real physical object, just like that.
Did I do it right?
Yeah.
So I can just pick it up and move it.
No, you can't do anything now. You can rotate your view. Select that, or you could use that, but select this little, there you go, select that, and now hold your left mouse, there you go.
Okay.
That's called free orbit. You sure can. All right, so she asked an excellent question. All right, so let's say we've got this part. So we've made this part. So this is feature-based modeling. So that means that we're actually going to build up our part based off basic shapes. And that's what we just did. We used a rectangle, 2 circles, and 2 lines, and we made a part. That's all we did. So now let's say that this part has some other feature we need to add to it. So what I'm going to do, I'm going to come grab, I'm going to start another sketch, and I'm going to select the top face of this part. You can select any face you want, but I grabbed the top face of that model. Did you start a sketch? Okay. What face are you on?
The front, I think.
Okay. Hurry up. So let's see what I do. No, I like to just kind of rotate to get my bearings. And yes, you are working. You see how you see your grid, your coordinate system. So you're on the very front of that part. So that's fine. Draw you something on it. Draw it. Let's draw you a circle. Whatever. And now, finish sketch. I'm gonna pick that out. Look what you just did.
Okay.
All right. All right. So now I'm sketching. All right, y'all are having a lot of fun. All right. So I'm sketching on the top of my part now. I created another sketch plane on the top of this model. So again, now you can do whatever you want again. You guys are pretty experienced with sketching at this point. So, come drop you whatever you want. And when you're done with it, repeat the process. Finish sketch, extrude. Here, I can make a little stud coming out of my part. Or let's say I want to go the other way. I want to put a hole in my part. There you go. I just put a hole in my part. Did I need that hole? Start 2D sketch. And just select 2D sketch. Now select whatever face you want to sketch off of. Just click it. Just click whatever side of the part you want to. All right, something's. Let's see. All right, you're already in a sketch. So what we're going to do, I'm going to delete that, just make sure we're on the same page. Start sketch, let's do this top face. And now, to get your bearings, I just select my free orbit, left click drag. You can see where your grid is now. So that's the face you're going to be drawing on. So now you can just start doing whatever you want on that face.
Thank you.
Would you like some help with anything? Okay. All right. So we need to go ahead and speed up the process a little bit. I've got a lot I want to show you. All right, so let's think about the steps we have taken. All right, so I've tried to give you the basic premise of solid modeling, of parametric solid modeling. So if you combine those different tools, those different processes, you can do some really complex parts, right? You can do some really complex shapes. Well, here's one of my students' most recent designs. Now, ignore the file name if you can see it, but any guesses on what this part here is? What? It does look like a bench. It's a park bench. It's a park bench, but it's a really small park bench. Do y'all have any need for a really small park bench? That's a great answer. So does anybody have business cards? Everybody here's got business cards, right? Everybody like a cool little bench to sit your business card in? Guess what? You came to the right place. Here's that part. Does this look a lot like what you see on the screen right there? Here we go. Everybody gets to walk away with one today, but you have to take one of my cards with you so you can send me students. That's the way it works. All right, so this is one of my student that just left. I tasked him with creating a really cool business card holder, and this was his idea. He just kind of like, I really like the idea of a business card sitting on a little park bench. I like that idea too. It's fine with me. I let the kids do the creative work. I'm not creative. So this here, and the young man that left, I didn't use this joke in the first class, but I'm going to use this joke now and tell me how good it is. His last name is Van Geisen. So this is not a Van Gogh, but it's a Van Geisen. It's much rarer, okay? All right, I won't use that again. All right, all right, so here we go. Everybody gets the gist of this. So this was printed. This was additively manufactured, and we have two printing in the process right now. And as you can tell, we have been a business card park bench production machine this week, getting prepared for you guys. So I'm going to turn over the stage now to Mr. Dawson, and he's going to talk about the process of taking that model and actually making a printed part out of it.
So we've already created the park bench in, this is an Inventor.
Yes, sir.
So we've already created this in Inventor. So this is what it looks like. I'll just swivel it around a little bit so you can see it. So we would then export this file into what they call a slicer, so used for 3D printers. Basically taking a solid model and slicing it. See, I was listening right in the first class. So it's just slicing that, and then this is what happens when it gets sliced. So as you can see, it's going to take about 5 hours and 32 minutes a piece. We were moving pretty fast along with those. We were printing about 4 at a time, so about a day and 2 hours per print, depending on which printer. So the slicer is where you choose all the things that you want to do with this print. So the print is going to remain the same. So you can actually choose how many walls you want around the outside, so how strong you want it. You can choose if you want like 25% infill. When I say infill, it's not a completely solid part. So I'll scroll down just a little bit. This triangle pattern right here, it's not a completely solid part. That's just there to take up space and keep it pretty strong without wasting so much filament and keeping the time down. But with a couple clicks, I can go to infill. infilled, so it's a completely solid piece of plastic that the printer is going to print in. It's double the time, but it's going to be much stronger. But for what it's doing, holding business cards, it doesn't need to be that strong. But you can see it goes layer by layer, so you can see exactly what it's doing on what layer. Here's all the different settings you can do. There is supports, so what Matt was saying earlier, you can't print from nothing. Well, you're printing from nothing, and then you're going to have something. But the printer it can't do overhangs. So if it starts to print on like a cliff, the filament's just going to fall down. It's got to have something to build upon. It just can't print into thin air. So we wanted this. This model is basically so it doesn't have to use supports throughout the printing this way. But if I was going to print it the other way, it can't print any of this. It would just fall. It would probably get about right here and then just literally fall on itself. So we can come over to supports, slice, and supports is going to take up more time anyway too because it's got to print more. And all that blue that you see, that's the support material. So now it can print any overhang you want. And then after end of the print, you can pull it off the bed and then safely remove all the supports, and it's going to be your exact part that you want.
Any necessary support material is not bonded like the actual part material is, so it'll just snap right off.
It actually has a buffer layer or a couple layers, and it's not really holding on by much, so you can literally just pop it off with your fingers, and it's going to be perfectly fine. That's those X's, the darker blue. So that's actually what is adhering to the actual part. So you can just break that off, take a small razor blade, or you can just peel it off with your fingernails, and it's going to come off perfectly. Gabe, do you want to add anything?
Well said, Dawson. All right, you guys have any questions for him? All right, so that is a pretty thorough explanation of how we could create this particular part in an additive environment, in an additive manufacturing process. Well, let's say that we wanted to use a subtractive process. Let's say that we wanted to actually make this business card holder out of aluminum. I mean, you're getting serious. You want to make sure your business cards don't go anywhere. All right, so you want an aluminum business card holder or whatever the part may be. So now we've got to shift gears back to the subtractive side, okay? Now we actually have to start with material and start cutting it away. All right, so if you will pull up Fusion. All right, so this is not the business card holder, but as you can see, I do have this particular part or product in this software as well. If you will simulate it. So bear with me, guys. This is just a part made out of aluminum, and it's got a lot of actions. And he's going to show you what a virtual simulation of actually machining this part. It's hard to say. You can speed it up a little bit. We're getting there. This is a step towards the CNC machine. Yes. So this is just walking us through the machining processes to create this particular part out of a piece of stock, and it just happens to be aluminum. All right. As you can tell, there's pockets, there's shoulders, there's radiuses, and there's drilled holes, and then those holes are tapped with a 1032 thread. The green regions are the finished part. That's a chamfer. That's a chamfer tool, cutting a slight chamfer on the edges of the part. Now it's spot drilling for your holes. Then we're doing a peck drilling cycle to actually drill the holes out in the material. and then finally it's actually tapping, it's actually cutting the threads in the hole. And it would have made a lot of sense for me to bring one of these parts in here, but I didn't. But we do have them in the shop. All right, so now if you will post-process that, but let me pause for dramatic effect. So everybody just, you've got a general idea of the modeling process. You've got a general idea of what we, in our CAM environment, how we set up the production process or machining process to create this part. But going back to her question, I mean, what good is it doing us? We still haven't physically produced this part. Now, on the additive side, we're physically producing parts, but on the subtractive side, we're still not physically producing parts. So what do we need to do? We need to go to the CNC machine. CNC machines, computer numerically controlled machines, run off of code. They run off of CNC code, G&M code. So post-process this, please. Yes. Post valid, or I should have been post all, but it's fine. Here is the code generated by that software to physically produce that part on a CNC machine. Does anybody know, anybody have any vague idea of what this code is saying right now? No, and you would be very odd if you did. All right, yeah, you've got some idea of it. And once you start to work with this code, you're going to start to pick up on it. There's G codes, there's M codes, but any time you see an X, a Z, a Y, it's Cartesian coordinates. That's all it is. It's telling the machine where to go and what to do. All right, that same code that will machine that part on the Haas CNC mill is the same code driving this printer right now to make it out of plastic. All right, so on that note, now we're going to shift gears and think about subtractive manufacturing. Well, we talked about CNC. Well, CNC machines are computer controlled machines, but what machines are they controlling? They're still controlling the milling machines and the lathes that were invented back, around the time of the Industrial Revolution, the Eli Whitney time frame, like we talked about early part today. So now Gabe and Dawson are going to take y'all into the manual shop, and they're going to do some manual demonstrations for you, and then we'll close out today in the CNC shop. Does everybody have safety glasses? If you don't, there are a couple of boxes right there beside that huge pocketbook you just moved. But so y'all want to stick on the mill and the lathe again? So Dawson's going to be on the milling machine at first. Gabe's going to be on a lathe. So just, if you will, split up into two groups, and then we'll rotate around.
Congratulations on this. I know you got some big day coming
Yeah,
up.
Monday morning, yes, sir.
Appreciate you being
Yep.
here, man.
Well,
All happening at one time.
oh, it's all good. It's all good. We're fortunate. Well, I say fortunate, but it's a scheduled C-section, so we've got so we've got an idea. Unless something changes, we haven't. But it's pretty surreal. We have a 12-year-old and a 5-year-old, and it's pretty surreal to think we have another one on the way. But it wasn't our plan.
You'll get to relive some of the fun moments.
Yep.
We got a 28-month-old now, and just those stages where they really start to learn to talk and explore and all that.
And this is I've got two little girls, and this is our first boy, so it's really changing things. And we didn't have, with our second one, we didn't have baby showers or anything, we had everything. But now this go around, we've had 3 baby showers, so we've been really blessed. A lot of people, just literally showered us with love, and we've got so much stuff, and all little boy stuff now, so it's going to be interesting. But my wife's just ready to get it over with. She's feeling it. We're pushing past the years that we should be having children.
got to use the one at Washington High School.
Did you?
I still got the thing made.
Really? What did you make?
It was like a little board, but it had my Jeep on it. It was pretty cool.
Was it a Pacific class or like an incident class? Was it Pacific CNC class?
Yeah, it was just carpentry.
Oh, really? Did it carpentry?
I was one of the only ones in the class. We just played around with it.
Watching you this the other day, I was thinking of you seeing you like, wow. This is the year we're gonna make some big, I guess, flags, like the whole cutout of like the river basin or something. We're gonna do some boxes, fill it in.
I'm sure that was cool.
We're gonna do that. I'm great about like
Oh, okay.
powder and stuff for it. I'm not like a fan. So that's our project for the
Is that that board behind Miss Barnes still up? Watch that.
If you have that,
I had to sand it. I had to go in and because it's like textured all through the center of it. I had to go in with a piece of sandpaper. Yeah, I got to look at that.
it looks so good.
I guess we're good to go. Okay. All right. Has anybody ever seen one of these machines before? You know how to run it. You did? Oh, okay. All right. So have you ever run one? Okay. All right. Does anybody else? Does anybody know what this is? You could drill with it. You could. All right. So what I'm going to do is I'm going to touch off with this part using an end mill. So an end mill is, although it kind of looks like a drill bit, it's not. It's not shaped like a drill bit. It's made for side cutting only. You can drill with it, but it's not really recommended. A lot of people do that, even though it's not recommended. I've done that. Anyway, so this is made for side cutting. So if you want to go around the side of a part to basically make it square, this is what you would use. So I'm going to go ahead and touch off. So what I'm going to do is I'm basically just going to tap it just enough to bring out just a small chip. So I know I can set my zero. Alright, so now that's touched off. Set my zero. I'm going to go in. And then I'm going to come across. Anybody want to run this?
I'm not here. Do what?
You've never run one of these before, have you? Alright, so you can turn this. It's going to move it closer to the watch this read out. We want this to say 25. So you're going to turn it counterclockwise. Yeah, it'll be positive 25, so you turn it there.
Okay, now it's right. I went that way first, and then it went, okay.
Okay, keep going. Okay, 3.
Oh, okay. Oh, 25, like,
Right there.
oh, okay.
Close enough. That's it. Alright. So then you're going to turn this. You can turn that one over there if you want. You're going to turn that one counterclockwise, and it's going to feed into the plug. So what you're doing now is conventional milling. So the end mill is spinning this way and the part's moving this way. So it gives a worse finish, but it's easier on the machine. It's just cutting away as it's moving. So when you go back across, so if you want to take another 25, you can. So just go to 50. And when you run it back across, pay attention to how much easier it'll feel now that it's actually pulling the material into it. So it's cutting like this, and then it'll actually start pulling into it. So this is harder on the machine, but it leaves a much better finish. Notice how much easier it is to put.
So that's the way that it's spinning, and that's why.
It's trying to basically pull it across. Does anybody else want to try? Set on 0 so you can turn it on 25. You're going to turn it counterclockwise. So that's actually 3 thousandths. You're going to turn this till it goes to the base. Notice, it's fine at 51. So you're going to notice how much easier it is to turn it the other way.
Now, what was the first name again? I forget.
My name?
Yeah.
Dawson.
Dawson. To put a step in that cut we're doing, we use a different tool or we use the same one?
You can use the same one. Did you want to put a step in it?
Yeah.
Sure. Does anybody else want to do this beforehand? Alright. Alright, so you're going to turn that counterclockwise, and you want this to say 2, 5. 2, 5. Alright, that's 25. So now you can feed it across. Go to 50. Alright, now pay attention to how much easier it feeds across this time.
Is that angle as well? If you were going to like wanted to cut a 45 on there?
You could. This machine, you can turn it. You can turn the head this way, that way. It'll swivel. Basically, any way you want to put, it'll do it. See how much easier it's feeding in?
Cool, thank you.
All right, does anybody else want to cut? You want to? Turn this counterclockwise until it says 0250. And it doesn't matter if you go a little under or right next to it. Okay? So you're going to feed that counterclockwise in. better for consistent speed. Depending on how fast or slow you feed it across, actually will depend on your. It will mess up your surface finish. It does make a difference. So if you want to turn that again, like counterclockwise, go to 050. Other way. Good enough right there. There you go. Feed it back across. Keep in mind how much easier you turn. The machine's basically trying to snatch that table away from you. How big of a step do you want to go?
Ideal take off this way and this way. What we can do.
So you feel it, if you have pull it or not. There's for everything. It doesn't really matter what it kind of does. If you want to adjust anything, go ahead.
Maybe one of my kids found a river card in one of these things, and he was so bad. Kind of cheap. Not really cheap, but I took advantage of everything. You feel it. We go ahead and move.
Yeah. Just like going back over that little table and things up anyway.
Has everybody wanted to get their hands on and able to over here?
I think so. Are we good for time?
I don't think we'll make it to Cincinnati, but I would like to get y'all on the lane and take the lane over here.
And I have broken one of these in. Yeah. In the seats.
The reason we're not running the ball for it is what about 40
I've been able to find high-speed steel system.
It might be easy because all you're doing is drilling.
So Dawson's going to talk y'all through manual milling now. Y'all were at turning where you had a rotating workpiece and a stationary tool. Now we're on a milling machine and you're going to have a stationary workpiece and a rotating tool. Exact opposite. And obviously you're working with cylindrical parts of the lathe, you're working with square, rectangular parts, what have you, in the middle. And turn it over to Dawson.
Alright. Has anybody ever seen one of these machines before?
Yeah.
You have before?
is your forward reverse. The forward is going to be your counterclockwise, reverse is going to be your clockwise. So when you come to this side, so you want to go forward. The forward is going to be rotating this way, so the shear will be feeding into the actual cutting edge. Let's break it to this. So you want something top of it. This little grid you can see around, it's ship right there. It breaks off the chip so that in case this build up, you can see it's going over here. A little bit longer. You're actually coming to that chip breaker. The chip breaker helps. So it doesn't launch up, nest up, start slinging all over the shop. This is all off really fast, and all the land. This aluminum is very fast. It's almost hidden. It's not hard. Grab this.